So let us suppose that we have a curve in 3 dimension and a particle which is moving along this curve. Now at any given moment in time, the coordinate of this particle is given by x, y and z. If we consider the position vector of this particular point with respect to an arbitrary origin, then this will be represented by the position vector r, which is a function of time t. So our position vector r of t, that's simply defined as the vector xi cap plus yj cap plus zk cap, where x is given by 2t squared I cap plus y, that will be t squared minus 4t j cap, plus our z value. So our z value is 3t minus 5k cap. So this is a position vector of the particle at any given moment in time. So let's label this as equation number 1. Our task will be to determine the components of its velocity, the velocity of this particle, and its acceleration at time t equals to 1 second, but it has to be along the direction of this vector I cap minus 3j cap plus 2k cap. We'll come to this part later on. First, let us begin by determining the velocity and acceleration of this particle. So the velocity of the particle, that's simply the time derivative of our position vector r. So that will be equals to, so time derivative of the position vector r simply means we'll take the time derivative of each of the components of x, y and z. So time derivative of 2t squared, so that will be 4t. So we have 4t I cap plus time derivative of t squared minus 4t, so that's 2t minus 4 j cap plus time derivative of 3t minus 5, so that's 3 k cap. So let's label this as equation number 2. Now we will obtain the acceleration vector. Our acceleration vector is the time derivative of the velocity vector. So that will be equals to time derivative of 4t, so that will be 4. So we have 4i cap plus time derivative of 2t minus 4, so that's 2j cap plus time derivative of 3, so that will be simply 0 because 3 is a constant. We have 0k cap. So let's call that equation number 4. So now that we have the velocity vector as well as the acceleration vector, we will determine their value at a particular instant in time, which is t equals to 1 second. So at t equals to 1 second, the velocity, the particle will be given by, so we'll substitute the value of t with 1. So 4 times 1, so that means by 4i cap plus 2t, so 2 times 1, so that's 2, 2 minus 4, so that's negative 2j cap plus 3k cap. So let's call it number 4. And we will determine now the value of the acceleration vector at time t equals to 1 second. So that will be 4i cap plus 2j cap. So this is number 5. Now we're coming to second part of the question, which is actually finding out the velocity and acceleration components in the direction of this vector I cap minus 3j cap plus 2k cap. So let's consider a vector b, which is given by I cap minus 3j cap plus 2k cap. So we want the components of a velocity as well as the components of our acceleration along the direction of vector b. So to find out the direction of vector b, all we have to do is determine its unit vector b cap. So b cap is defined as take the vector b and divide it by its magnitude. So that will be equals to, so we have I cap minus 3j cap plus 2k cap divided by the magnitude. So magnitude of vector b will be simply square root of, so we will take the square of the components of each of x, y and z and add them to each other. So we have 1 plus 9 plus 4. So that means we have 1 over square root of 14 times I cap minus 3j cap plus 2k cap. So this is the direction of our vector b. What we have to do, we have to obtain the value of the velocity, component of the velocity vector calculated at time t equals to 1 along the direction of b vector. To do that, all we have to do is take the dot product with b cap. So this will give us the component of the velocity along b cap direction. So our velocity vector v is 4i cap minus 2j cap plus 3k cap. So this will be dotted with 1 over square root of 14 times I cap minus 3j cap plus 2k cap. So we have 1 over square root of 14 multiplied 2, so we have 4 times 1, so that's positive 4, negative 2 times negative 3, so that's positive 6, plus 3 times 2, so that is positive 6, which is equals to 16 over square root of 14. So this is approximately 4.27 units per second. So this is our velocity component, and we also have to find out the acceleration component along the unit vector. So that means we'll take the acceleration vector and dot it with b cap. So acceleration is 4i cap plus 2j cap, and this will be dotted to 1 over square root of 14 of I cap minus 3j cap plus 2k cap. So that's equals to 1 over square root of 14. So 4 times 1, so that will be positive 4. 2 times negative 3, so that's negative 6. So this will be equals to negative 2 over square root of 14, which is approximately negative 0.53 units per second square. So these are the components of our velocity as well as acceleration along the unit vector b cap, where b vector is given by I cap minus 3j cap plus 2k